Hello everyone and welcome to this 8th lecture which is of this global navigation satellite systems and applications. And so far we have discussed 3 main navigation systems. One is GPS, GLONASS, and in the previous lecture we have also discussed the Chinese one, which is BeiDou. Now very importantly we will be discussing now our own Indian system, which is Indian Regional Navigation Satellite System. This is what it used to be called. Later on it has been renamed as NAVIC, and this system is again completely different than what Chinese have planned, or it is different than GPS and GLONASS. So all those details we will be seeing in this lecture. As you know that NAVIC means sailor or navigator in Sanskrit or in Hindi. Also in some different languages is there. When I discussed the BeiDou, I also kept the name of BeiDou in Mandarin. So in the same way I am also keeping NAVIC name in Hindi also. And basically this NAVIC has been framed using this navigation with Indian constellations. That makes NAVIC, and which is again is a autonomous institute of India. It is regional, and of course is a completely satellite based system. So it is completely independent from all 3 systems which we have discussed, GPS, GLONASS and BeiDou. And IRNS will be, as I already mentioned, independent and autonomous. Of course regional navigation system aiming to have the surface area around 1500 kilometer, because it is a regional system. So we are focusing only in India and surrounding regions. IRNS is or NAVIC is being developed by Indian Space Research Organization ISRO, and would be completely under control of Indian government. Now what we see that basically why, when we are having 3 systems in place, GPS, GLONASS and BeiDou, and their signals are also available in India through our receivers, then why India is planning or having its own system. See this the genesis of NAVIC or IRNSS started basically because of the Kargil war, which happened in the year 99, and at that time US did, at that time only one single system was existing, which is GPS, and US did not allow our army to have accurate signals or highly accurate signals, and they introduced during that time the selective availability as well over the Indian part, and that created problem for our army. So after this war it was decided by India government to have our own system, though it may be regional, so that we can plan things, we can control things by our own way rather than depending on GPS or GLONASS or BeiDou. So that was the main purpose of the Kargil war. In that way was watershed, and that compelled the Indian agency, that is ISRO, to develop this system. And as you know that GPS could have provided vital information during Kargil war, but the access was denied to India, and that created hell of problems to Indian Air Force and other sections of army because of the poor signals quality which we were getting during those days. So this has made basically the importance of indigenous navigation system, which finally India has got now, which we will be seeing in few seconds the detail. It is of course to become self-reliant and to keep a close watch on the boundaries and in the neighborhood as well. So this NAVIC will have is 7 satellites constellation. It is not global, so that is why limited number of satellite would be sufficient. 3 satellites in geostationary orbit. Geostationary orbit we have already discussed. The movement of satellite has been synchronized with the movement of the earth. So, as earth moves, the satellite moves. So, in relative motion they are stationary to each other, and the remaining satellite, that 4 satellites, would be in the geosynchronous orbit, which also we have discussed in the previous lecture what is geosynchronous, and which the satellite overpasses exactly and same every day, same time and same location. So, with the required inclination and equatorial crossing in 2 different planes. So, these are in 2 different planes, these geosynchronous satellites are there, and all the satellites starting from IRNS 1A to 1G of the constellation are configured identically, and especially the clock part, that is most important thing. So, they are all having a synchronized clocks, and the now system is in place. Only we are waiting for some encryptions or other things, so that or de-encryption, so that in our maybe mobiles or receivers in very soon we will be having signals from our NAVIC system as well. But as I understand that Army, Indian Army is already having accurate positioning through NAVIC as well. So, it has already been opened for Army, but for civilian I hope that it will be opened very soon. So, IRNS constellation is a combination of GSO, that is geostationary geosynchronous orbit, and IGSO, that is inclined geosynchronous orbit of satellites are there, and these 7 satellites, as we have mentioned, are all here, and the control segments and monitoring stations are also will have in this different components of IRNSS, which we will have. So, there is also some additional things are there, like laser ranging and coma ranging, which is also in case of Baidu, and then you are having uplinking from this location, and then you are having master control station and other things are there, which makes this complete architecture of IRNSS. It is in comparison where IRNSS stands, and the major difference, as already I have mentioned, that 3 systems which we have discussed so far, GPS, Galileo and Baidu, which are global system, whereas IRNSS is regional system. A number of course, when you compare these characteristics of these systems, the number of satellites are reduced or less in case of IRNS, like Galileo, number of satellites 40, in case of number of satellite in case of GPS, minimum constellation is 24, but the 31 are there, few are spares, and in case of Chinese, the total number of satellite would be 35, and there are 20 are already in the orbit. And as you can see, in case of India or IRNS NAVIC system, 7 satellites, 5 are already in place, and very soon we will be having other satellites to complete the constellation over India. The coverage, area coverage, as you can see, it is 1500 kilometer radius, whereas in 3 other systems is coverage is global. In case of GPS, it is also global, and in case of Baidu, it is also global. The GLONASS is also there. Now, Galileo is though it is mentioned here the global, but currently it is regional. Maybe in future it might become global, but the main purpose there, this is what they have initially planned for regional system. Now, our regional system, as the stations which you have seen in the this slide, different locations are there for monitoring, master control station and other things. So, this IGSO is here in this part, and these satellites are at different locations are there. some are with reference to the earth movement, they are stationary, so all the time the signals would be available. So this geosynchronous earth orbit and geostationary earth orbit satellites are located at different locations, all 1, 2, 3, 4, 5, 6 and 7. So all the constellation here is completed, and these Geo 1C and this one, they are all at the equator, and this IGSO inclined geosynchronous orbits, they are at different, and the orbit is something like this which you are seeing here. So with this arrangement of satellites, India and surrounding countries will have the coverage or signals which we will be receiving. So will provide the accurate real time positioning and timing services. This is what is expected. Very soon we will, civilian people will also have the data from IRNSS. And already mentioned, it is going to cover 1500 kilometer area, radius area, and currently the system constellation 7 satellites, 2 additional satellites on ground for standby are there. This is about a global perspective from GNSS point of view, that which countries are having which systems or operating which systems. As you can see, the US belongs to GPS belongs to the US, then GLONASS is Russian, also shown here, and then Galileo is of course European, which you can see here, and then Baidu is a Chinese one, and then IRNSS is for India, and QZSS, which we will be discussing in next lecture, is about or maybe after that is of Japan, which is purely again a regional system. But as you can see that many systems are global, so many countries may not be developing their own system, but for security purposes or for army purposes, some countries might come up in future for their own systems. IRS will provide again like other navigation systems. So IRS will provide 2 types of services: SPS, that is standard positioning service, which is provided to all the users and including military and civilians, and restricted service which has already started and which is an encrypted service provided only to authorized users, that is mainly for Indian army people. IRNSS frequencies, if we see again, it comes in the, this is the part of EM spectrum where the L band is shown here, and in this part we are having IRNS will transmit the data in L5, that is 1164.5 and 1188.45 megahertz, and S also in the S band, instead of not only focusing L band, because now it is already occupied by other systems. So one more band is being used here, that is the S band 2483 to 2500 megahertz bands. So these 2 bands, L5 and S bands, are going to be used by IRNSS for standard positioning services, and this L5 band has been selected to in the allocated spectrum radio navigation satellite services as indicated in this figure for L band, and 4 for S band also. So that you can see here. Now if we compare with other systems, then this is the location for IRNS L5 band, as in see in the pink color, and this is the range which is going to have IRNS band are here, and then Galileo band in blue color, Galileo SAR downlink in red color, and GPS bands are in yellow color. So IRNS band also L1 might be used by India also, but currently it has been planned mainly to use L5 and S band of a microwave region of electromagnetic spectrum. Now these standard positioning services will be using 2 bands, as already we have discussed, of these carrier frequencies, and the bandwidth is going to be 24 megahertz, L5 is quite broad in that sense, and then here the 16.5 megahertz band for the S band, and these are the this for standard positioning service. This is what we are going to have, and these spectrum of S band is also shown here. The ranges are here, and in between this the frequency has also been allotted, and so this is that frequency which is going to be transmitted signals to from the IRNSS. IRNSS system time started, reference time is there, so 00 Sunday August 22nd 99. Each system navigation or GNS systems are having their own sort of start or reference time, and that is midnight between August 21st and 22nd. We started 00 hours that our system clock, and or for calibration purposes in IRNS system time is ahead of UTC by 13 leap seconds. So like in case of Baidu it was 100 nanoseconds, but here we are having 13 leap seconds, that is IRNS time August 22nd when we started 99 correspond to UTC time of 21st, because UTC is behind in that sense, 21st, 23, 49, 47 hours. So this is the difference between UTC and, but in civilian domain may not be much important, but for army purposes and some for very accurate positioning estimations, these things will matter. And if somebody is exploiting 3-4 systems through their receivers, then they during the calculation or these things have to be maintained or corrected timing so that we get the correct estimation. Of course, these things can be done through the installed programs with these receivers, or maybe through the post processing. These corrections can be performed over the signals coming from different GNSS system. Now other primary navigation parameters of NAVIC system is the satellite ephemeris, satellite clock correction parameters, and satellite and signal health status. And then the last one is the user accuracy and maybe total group delays there. Now the secondary under this category of secondary navigation parameters, we will be having satellite almanac and then ionospheric grid delays and confidence. That will be again based on some modeling, and then IRNS time offset with respect to UTC, which we have just discussed. There is a slight difference in this these timings between IRNS and UTC, and ionospheric delay correction coefficients, those will be also applied in the secondary navigation parameters. So the first one, primary will have ephemeris, whereas secondaries will have almanac. Then primary will have clock corrections. Here the main important part is the ionospheric delays, corrections, and then time offset in the secondary parameter. Others are signal health status, user range accuracy, and total group delay. Those data will be coming to a receiver, and maybe some text messages in the secondary navigation parameters. Differential corrections might be there. Earth orientation parameters will also be there. So the position accuracy, as we see, because it's a regional system, so we talk in a for civilian domain, this is going to be the 20 meter over Indian Ocean region of 1500 kilometer around India, as shown here. At different locations the accuracy may vary, that is why they are there. So less than 10 meter accuracy over India and adjacent countries might be there, but if you go quite far then there will be different accuracies, because the entire focus of this IRNSS or NAVIC is over India, Indian subcontinent, India and neighboring countries. IRNS receiver will be dual frequency, because L5 frequency is being used and S band frequencies are also being used, and or maybe a single frequency, either it will have L5 or S band with capability of receiving this ionospheric corrections, so that our position estimations becomes much better. And receivers will be able to receive and process navigation data from other GNSS systems or constellations. And the 7 IRSS satellites, that is the complete constellation of IRNS which has been planned, will be continuously tracked by the user receiver. It is because most of these satellites, many of these satellites, they have been designed, or the orbits have been designed in a manner that from almost all locations, if somebody is in open area, will have access to all these 7 satellites. And that is why sometimes you may get better accuracy estimation or position estimations than compared to other systems. So, applications of IRNS, as we know that all GNSS systems will have the almost same type of applications: terrestrial, aerial, marine navigation. In disaster management, at that time it plays a very important role: vehicle tracking, fleet management, integration with mobile phones. Of course, mobile phones are coming with a lot of apps and map and other facilities are there. Of course, precise timing is one of the key applications for various purposes are there, various applications, and then mapping and geodetic data capture where one can also exploit the IRNSS system, terrestrial navigation for hikers, travelers, and other people, and visual and voice navigation for drivers, that might be also there. So, in this what now let us talk little bit about the accuracy part and with comparison to the GPS. As you can see that all these satellites, 7 satellites have been shown here, and 3 are in the geostationary orbit and rest are in the this IGO inclined geosynchronous orbit. So, this GPS, as you know, that having 31 satellites constellation, whereas IRS will have only 7 constellation. GPS is global, IRS is regional, so it is fine. And so how we will get an accurate location from IRNSS, because earlier it has been mentioned by then Chairman ISRO Kiran Kumar that 24 functional satellites of GPS is for the entire globe, while 7 satellites of IRNSS is covering only India and its neighboring countries. So, all these 7 satellites will be visible to ground receiver all the time. This is most important thing. In case of GPS, if you use only the signals from GPS, all the 7 satellites or any 7 satellites out of 24 will not be available. But in case of IRNSS, at every location in India, one will have access of all these 7 satellites signals. That is most important part of IRNS being focused over India and being regional system. Further, in case of IRNSS, the 7 satellites are in geosynchronous orbits, hence always visible to a receiver in a region which is 1500 kilometer around India. Another point is that the satellites are nearly vertical over India, and therefore visibility in urban canyons which much better than in case of GPS, because these are deep in space. But if you say connect a trajectory, then what you will see that even if you are surrounded by buildings or mountains, that signals are coming vertically downward rather than from inclined orbiting satellites, and therefore the signal quality is going to be much better and position estimation. This is what it is expected. Further, the Tapan Misra, who was then director of Satellite Application Center SEC Ahmedabad, he said that NAVIC is going to be better than GPS. While GPS is using L band signals, NAVIC is going to be use both L band and S band. These 2 bands it is going to use, since our signals are coming vertically. This is important, vertically downward from stationary reference, with reference to the earth, they are stationary. Our NAVIC is going to work better than GPS in crowded places. If we use L and S bands our accuracy is more than 5 meters, and this has a better potential than a 20-meter accuracy of GPS. Well, sometime if you are in an open area, you may get a better accuracy from GPS, and when this IRNSS signals would be available, when we will go in open area, we may have again better accuracy than even 5 meters. And nonetheless, so currently an average accuracy is around 20 meters in case of GPS, which is actually supplemented by GPRS information, that is augmented or assisted GPS. So our IRNSS can also be assisted, and then accuracy can be improved. But our NAVIC can give you accuracy that GPRS and GPS give combined, and that accuracy is not only for cities but every rural part of the country. Almost every part of the country will have signals and better quality signals and better position estimations. And further he mentioned that when we speak about accuracy today, we have Gagan, which is a ground augmented navigation system which India developed earlier, which uses GPS signals, because we did not have our own IRNSS signal, and additional information provided about the position of these satellites. And then it tells you which GPS satellites are giving you a more accurate position, and it corrects the errors of GPS, because basically the error part is getting being communicated from ground stations to a receiver. So therefore it corrects the errors in GPS signals with the help of 24 receiving stations spread across the country. With all these ionospheric corrections that are required for instant computation, the information is provided in Gagan. So that is how Gagan enables you to get better accuracy than GPS. But Gagan, the disadvantage with Gagan is a ground augmentation system. And now we are talking space augmentation system, which comes under the category of SBAS, and we will be in future lectures we will be touching these parts also, the SBAS of or similar technologies by different countries, which are this augmentation, that means the error part is being transmitted not from ground stations but by space based or satellites. So it is certified by the Civil Aviation Ministry for safety of life and integrity is guaranteed for the Gagan. It means that if you get any position in the Gagan enabled receiver, then you can depend on it for the safety of any life activity. And these aircrafts, they are using the signals from the Gagan as well. And further he mentioned that Gagan is using GPS signals, whereas when we will have our own signals, the same Gagan system can be upgraded, so we will have much better accuracies. So imagine a situation when 7 dedicated satellites which are visible to the ground receiving station 24/7 will provide signals. It is going to be definitely much better. So it brings to end of this discussion on IRNSS, and in future we will be discussing over about the Galileo and then QZSS, and also we will be discussing about SBAS or space based augmentation systems. We will not be focusing in this course about the ground based augmentation system, but some details we will be having about the Gagan as well, because it is our own Indian systems. So as usual I am leaving with a cartoon for your fun. Thank you very much.